Hey there everybody, Infusion here, and today I'm going to give you a video showing you exactly what FM synthesis is and how it works on a very basic level. For this tutorial, I'm going to be using a program called Flowstone, which is also known as FL SynthMaker. Now what Flowstone / FL SynthMaker basically is a visual programming environment, but when within FL Studio, it's mostly used to create your own synthesizers and effects for use within the program. However, it's a really good tool for visually showing you the math behind what's going on in audio and information. So I think it'd be a good fit to illustrate to you how FM synthesis works. So before we can create FM synthesis, we first need to create just a very basic synthesizer structure. So we're going to need a couple things. First, we're going to drag in our oscillator here, which is going to be a sine wave. And secondly, we're going to need a value, which is just going to specify the cycle rate of the oscillator. So we're going to use a rate of 440 hertz, which on a music keyboard is an A note. So let's just put this together. I'll move you over here. Let's just connect this to our audio out just to see that it's working. And it is indeed working. So the next thing we're going to want to do is just add a volume knob here over our stereo out so we don't have to listen to an obnoxiously loud tone. And just to monitor, I'm going to throw in some oscilloscopes here. So here's our sine wave. And here's our output. There we go. So next thing we're going to need to do is just to create a switch here, which we'll want to use to turn the tone on and off. To do that, I'm going to use an ADSR envelope just with sustain set to maximum. And we're going to turn on the gate so we can trigger the envelope. What this switch is going to simulate is basically just a MIDI on and off signal for when you press a key on your keyboard. So we set that. And now this switch should trigger the sound. Oh, forgot to connect this. There we go. So now we got just a basic tone with a button that we can use to turn it on and off. So what can we do next? Well, the next thing we can do is just add a knob to our frequency rate here so that we can more easily control the value. So we'll say we'll go up to 880, which is double 440, which means it'll be an octave higher. So 440, 880. You can hear those are both A notes. So let's go back to 440. Right, so we have our basic synthesizer set up. So the next thing we're going to need to do is copy this oscillator and add a second oscillator. Let's just move this out of the way and copy all this stuff. So let's copy and then paste. All right, so now we have two tones and we can add them together. So that's a sine wave at 440 hertz and a sine wave at 880 hertz. You can actually kind of see here with the oscilloscope that the 880 hertz is just like double the speed of the 440 hertz. So that's how most basic subtractive synthesizers will work. They'll take more than one oscillator and add them together to play at a note trigger. But what if instead of that, we use this to control the frequency rate of our initial oscillator. Well, to do that, we're going to need to make a data conversion because this blue data type is different than this green data type. You can see here, we're getting these normalized values of 1 through -1. And with our cycle rates, we're dealing with numbers in the hundreds and thousands. So we're going to need to multiply. So to do that, we're just going to add one of these knobs, which is basically just multiplying this blue data. So let's set our multiplication value at 4,000 times and set that to 0. And this is where FM synthesis happens. So you can see that we're getting kind of funky tones. That may seem a little weird, but let me explain it in a way that most people who understand subtractive synthesis will understand. So if we just take this cycle rate and set it to 1, we're essentially creating a low frequency oscillator. And that's just slowly modulating the pitch of our initial sound. Like you can hear, because it's really slow, that it's just slowly going up and down. But when you start pushing the waveform frequency into the audible range, that's when you start getting FM tones. Now, this is a really basic example, but you can get really kind of crazy with FM synthesis. There's only so many things you could do with just combining two oscillators together like this. For example, you could feedback an oscillator into itself, or you could have 5 oscillators all oscillating each other. There's a lot of possibilities, and it can get really complicated. But just for this tutorial, I explained to you the basic 2-oscillator FM system. So if you want to try this for yourself, we can actually do this in Audiotool. So let's make FL-Chan dance and switch over to Audiotool here. So you can see, whoa, hang on. Oh, there we go. Let's just pull in a pulv and make it like our project. So it's just going to be a sine wave at A. And we're going to use the envelope with just max sustain. So now we have a continuous tone. So we can actually use the LFO as the second oscillator. In this case, it's set to sine. And we'll assign that pitch to OSC1. You can hear it changing the pitch of our initial sine wave. But again, if we use the rate knob, we can actually push that into FM territory. You can actually use the depth knob to specify the amount. And try different oscillators with different depths and rates, just to explore some of the basic possibilities that you can do with subtractive synthesis in Audiotool. Anyways, I think that's enough. Oops. Get back here. Right, so that's the basics of how FM synthesis works. I hope using Flowstone has kind of given you a bit of visualization into how the waveforms interact with each other, and actually seeing the numbers can help you understand what's happening with FM synthesis. As always, this is Infusion signing out. Signing out.